Hi class, this video is just to kind of help with the probability. I know probability is kind of a tough topic to learn because there's so many little parts. So this one is going to be over probability distributions and expected value, and it's 5.1. We're not going to do the rest of chapter 5, we're just going to do 5.1. So let me go ahead and share my screen and show you. Okay, so the first kind of idea, I'm going to cover this up as I go. The first kind of idea that they bring up is just a random variable. A random variable is just our x, and it's just what we're taking the probability of, or the name of what we're taking the probability of. They call it that it has a single numerical value, and it's determined by chance for each outcome. It'll make a little more sense in the table, but for example, if I'm flipping a coin, my x values are heads and tails. Like those are my outcomes, and that's my random variable. So probability distribution is just, if I'm doing a full event or an experiment, couldn't think of the word, what are the probabilities of every single thing in that? So it's a full range. So for example, I could be rolling a dice and I could get a 1, 2, 3, 4, 5, and 6, and each one would have the probability of 1/6. And those 1/6 on all of them would add to the number 1. So a probability distribution should add to the number 1. So when you're doing your homework, it'll say, is this a probability distribution? So you have to look at, does all the probabilities add to a 1? Okay, so that's the idea of a probability distribution. Here's my first example. If I'm going to toss a coin, the x, the random variable, will be the number of heads when 2 coins are tossed. So I have 2 coins. So here's my x, here's my probability. So what are my possibilities that I could get? Well, I could get 2 tails. I could get a heads and a tails and a head. I could get a heads and a heads. So this is looking at the number of heads when 2 are tossed. Another way to think of it is on a tree diagram. So how did I get these probabilities? So I thought, okay, I could get a heads or tails and on the first toss, and no matter what I get on the first toss, I could get a heads or a tails on that second toss, which led me to 1/4 probability on each. But we're looking at the number of heads. So in this row, we had 2 heads, which is here, 2 heads, and we have 1 out of 4 probability. And then if we got a heads and a tails, we got 1 head. But also if we got a tail then a head, we got 1 head. And that's where the probability is 1/2, 1/4 and 1/4. So here's a probability distribution. We have all the x values that could possibly happen, and our probabilities will add to the number 1. Okay, that's all it is. So a lot of times we give you your data in a probability distribution. Okay, here's my second example. Is this a probability distribution? Okay, so I already wrote the answer on the side there, but is this a probability distribution? So on whatever this was, you could get the number 0 through 4, and I give you the probabilities, and if you add those up, they add to 1.4. So I'm just adding them. Nope, that's not a probability distribution. Okay, the next thing that you could be asked, it's a little more tedious, is what is the mean of the probability distribution? So now I want to know the average of the probability distribution. The way that I'm going to calculate that, the symbols look scary, but this means mean of a probability distribution. It's just like a little bit of a cursive U, the Greek symbol. And then we're going to do the sum. That's what this E, not really an E, but looks like, right? It means sum. So we're going to add up x times the probability. So if this is our probability distribution here, gosh, I can't remember what this data was. I think it was like Payne scale or something. I don't know. It was actual data that I got. So these actually add to a 1. So it is a probability distribution. And I'm not going to trick you when I ask the mean. So what we have to do is we have to make another column and we have to times these together and we add these up and that is going to give me my mean. So I'm going to say that again. We're going to times the probability and the x's together because this is my outcome, 0, and times it by the probability that's going to give me 0. And then I add those up and it gives me my mean. So the mean of this data is around 4. Well, it does look like it's about in the middle. So it looks pretty accurate. So again, I added them up after I times them together. So this is our mean. The next thing you might be asked is, what is that standard deviation? So how spread out is my data? Remember, standard deviation is just a way to see how spread out the data is, like range. Standard deviation and range go together, or mid-range. And so we're in here, and it's telling us now a little bit different. It's saying, okay, you're going to take the square root of adding up the x minus the mean squared times p. Or you can add up x squared times p and minus the mean squared. These both get you the right answer. This one I found to be easier. So I'm going to square all the x values. So I'm going to take all of these and square them, then times them by this, add them up, and subtract it off from this squared. So if I did that from the same data, okay, then what I'm going to do is I'm going to square your x and times it by the probability up here. So 0 squared is 0. 0 times this is still 0. 1 squared times the probability, well, 1 squared is 1, so it stays the same on that one too. 2 squared is 4, so 4 times this got me 0.384. So you see what I did? I squared and times it by these probabilities, and that got me these. Then I'm going to add those up, okay? I'm going to add up that row, and I'm going to subtract off from it my mean squared. And that's going to give me, and then square root. That's going to give me about 1.4. So this data is spread out about 1.4, where it's, yeah. Okay, so our standard deviation. So those are a little tricky. I found them easier in Excel than I did in StatCrunch. In Excel, you could actually just take your one row and times them together and make a new row. So if you want to do this on technology, you can. And I suggest using Excel, even though we use StatCrunch for almost everything. This is one thing when I'm making another row, it's easier in Excel. If you're not good on those, you just use your calculator, no biggie. Okay. Kind of on that same lines is expected value. So expected value is kind of like what it sounds like. What are you expecting to get out? Kind of close to the mean. Oh, it is. So our expected value is the mean. It's like, what are you expecting to get out? I love the expected value when it comes to gambling. It's just a great example of what you should get out, or insurance companies. So my first example here is you're going to pay $5 is what this kind of was, and to get a ticket. And the probability of winning nothing but losing your $5 was 85%. So if you pay $5 for something, you've lost your $5. Okay? The probability of winning $10 was 0.1. The probability of winning $1,000 was 0.05%, or 0.05%. So what we did to get our expected value was we times these together, times these together, and times these together, and add them all up. So the expected value is $46.75. That's great. In a real situation, the expected value is negative a lot. So they're expected to get more money than they give out. It's how they still have gambling, right? They have to be able to win. The company or the casino has to be able to get money. Okay, so here's another one, and I like this one because it used some of the ideas from the section before that were a little confusing. So this one says, pick 5 lottery game, totally the Powerball if you take off the power part, just the 5. You pay $2 for each ticket, and you pick numbers between 0 and 9. If you win, you collect $500. So we're starting, we don't have the table. We're starting with having to create our own table using our probability skills. Okay, so the first kind of thing I think of is the numbers 0 through 9 are 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 numbers. Okay? So if I look at how many selections are possible, I'm going to have 10 for each number. I don't have to, like, if you pick the number 2, you can't have a 2 again. I could have 2, 2, 2, 2. They don't have any restrictions. So we would take 10 times 10 times 10 times 10, which is 100,000. So there are 100,000 ways for you to pick a ticket. Okay? If there's 100,000 ways, how many of those is the winner? If I pick one winner, okay, then it's 1 in that. So the probability is 1 in 10,000. Your book likes to write that as a decimal, which is 4 zeros. I'm going to write that here. This is the same as 0.00001, because you skip the ones, right? So it goes tens, hundreds, thousands, 10,000s, 100,000s. Okay, so if it gives you the E on your calculator, it tells you how many places to move your decimal. So for example, if I did 1 divided by the 100,000, it's going to say this. So it's the number 1, moving the decimal -5, so 5 places to the left, and the decimal's right here. 1, 2, 3, 4. I would need 4 zeros before the 1 to move it to 5. So your answers might come up strange on your calculator too, and you can just move your decimal. However many places it's negative, it's to the left, positive to the right. Okay, so that's our probability of winning. Oh, so low. So if you win, what is your net profit? So that's another question they asked that I wanted to make sure we thought about. Our net profit is minus what the ticket cost. That's all. Your net profit. Okay. $500, but you paid $2, so you really are $498. I'll take it. All right. So if we did our expected value, we would have to think about our net profit times our probability, but we have to think about how much, what is the probability of losing? Gosh, I couldn't get that out very good. So I take this number, oops, you can't even see what I'm pointing at. I take this number and I minus it from 1 to get this number. So if the probability of winning is 0.00001, then the probability of losing is 0.9999. You're going to probably lose. So if we lose our $2. So we times those and we get this number. We times those and we get this number. Then we add those and we get our expected value of losing $1.99.5, basically losing your money. This is real, except I left off the Powerball. This is the probability of winning the Powerball. Now, we all hope we're going to be that one person that picks. And in the Powerball, you could have to share too, but we didn't take that into consideration here. So this problem's from your homework, and it brings in, again, that probability of timesing things together to get your probability. You could have to use, if it's like 20, choose 2, you had to use the permutations and the combinations. That wasn't in this section, it was in the one before. So hopefully you watched a video on that as well. But I just made a quick video to hopefully help clear up 5.1 and that idea of expected value, which is our mean, right, our average, and kind of using that in our probability.